My name is John Johnson. That's real original, isn't it? I am what's called the outreach coordinator for the Omaha Astronomical Society. The society has been in existence since 1962 as an organization. We have been very active over the years. You know, membership kind of ebbs and flows depending on what's going on in the country. I've only been around since about, as part of the club, since about the mid-90s. Well, I'll take that back. I was here when Halley's Comet came around in the mid-80s, and of course membership and all excitement grew very much. Kind of ebbed out, and in the mid-90s we started picking it up again, and we've been very active ever since, doing a lot of outreach with scout groups, school groups, public events. Our membership, I think we're about 120, 130 right now. It varies. We have meetings the first Friday night of every month, unless some kind of holiday interferes with it. Last meeting was last Friday. It was standing room only. I think we had over 100 people show up for a meeting. So we have a lot of fun. So I'm here to try to give you some idea of what to expect in 2 weeks. That's right, 2 weeks from today. We're going to have an eclipse. So with that, we'll start it off. Frankie, I'm just trying to give you a high sign here. Should be able to just click. Now, a lot of these go, sequentially. Okay, so what's the big deal? We're going to have a solar eclipse right in our backyard. Well, maybe not right in Omaha backyard, but figuratively speaking, yes, right in our backyard. We're going to have a solar eclipse cut right across the United States, right across Nebraska. Obviously, eclipse day is August 21st, 2 weeks from today. So why is it called the Great American Eclipse? I'm sure you've heard somebody say it's the Great American Eclipse. It's because the only landfall for the path of totality will be on the mainland of the United States of America. But you must be inside the path of totality, I'll explain that more later, to really see the best part of a total solar eclipse. Now, I saw my first partial in 1963 as a kid on a farm out there in central Nebraska. I have never seen a total, so I've been technically waiting 54 years to see a total. I mean, they're around, but it's, to have one this close, definitely take advantage of the opportunity. Okay, there again, solar eclipse right in our backyard. Maximum duration of totality, which means when the moon is fully covering the sun, is going to be about 2.5 minutes, give or take a few seconds depending on where you are in the path. If you go south of here, south of Lincoln, south of Omaha, down where the center line is, and I'll show that in a second, you'll expect to see anywhere from 2 minutes 35 to 2 minutes 38 seconds of totality. Okay, next slide. So, okay, what is a solar eclipse? Here's a short video that gives a quick overview of what will be happening and what a solar eclipse is.
On August 21st, 2017, the Earth will cross the shadow of the Moon, creating a total solar eclipse. Eclipses happen about every 6 months, but this one is special. For the first time in almost 40 years, the path of the Moon's shadow passes through the continental United States. Everyone there will see the Moon at least partially block the Sun. People within the path of totality, shown here in red, will witness a total solar eclipse. For them, the Moon will cover the Sun entirely. The sky will become twilight, the air will cool, the stars will appear, and the black disk of the Moon will be surrounded by the pale, streaming halo of the Sun's corona. Totality will last for 2 minutes or a little more, and it will be visible along a swath that crosses the continent, from Oregon to South Carolina. For some, it will be the spectacle of a lifetime.
Okay, let's go back and look in a little more detail as to what is going to happen. First, I'll have a simple graphic that shows the required alignment to have a solar eclipse occur. Very simple sketch. You got the one on the sun here on your left, you got the moon in the middle, and you got the earth on the right. That's the alignment you got to have. Now, it's a little more complicated than that. Next slide. So why don't we have a solar or a lunar eclipse every month? You know, the moon goes around the earth every 29.5 days, so well, wouldn't we have one every month? It's not that easy. It's a little more complicated. The moon, than the moon just being between the sun and the earth, or the earth being between the sun and the moon for a lunar eclipse. Okay, here's a graphic that tries to start to explain why that happens. You see up here called the plane of the ecliptic. That's the orbit of the earth around the sun. Think of it as a gigantic pizza disc or pizza pan with the sun in the center and the earth rolling around the edge like a marble in that giant pizza pan. So it's all on one plane, like one giant sheet of paper. However, the moon, which orbits the earth, is inclined at an angle to that ecliptic plane. There it says 5 degrees, 9 minutes, 5.2 degrees, somewhere around there. So it's at an angle. So many times during the year, when the moon gets new, the shadows are going to miss above or below, or the same thing when you know, as far as a lunar eclipse. It's only when all that alignment works. The next graphic will kind of show that a little more. So you see there's a couple times a year as this rotates around the sun where we come into what we call a favorable condition where the angle of the moon's path will intersect the angle of, or the orbital plane of the earth. Clear as mud, right? Everybody got that? Okay. That's why we don't have an eclipse every month, and we rarely have them every 6 months. Okay, as we can see from these diagrams, we can only have a chance for a solar eclipse somewhere on Earth about every 6 months. However, the chances of one occurring at any given spot on Earth is about once in 375 years. So, when was the last one in Nebraska? Well, let's move on. I think I got a slide here pretty soon. Here's a look at past solar eclipses up to including the one that we'll have in 2 weeks on August 21st that have crossed over some portion of the United States. Okay, let's study this one a little bit. Everybody see this? Okay. Obviously, here's the path of the one on August 21st. And that's why everybody's so excited. Cuts right across. The last time anyone cut anywhere in the United States was this one in 1979. It was February. The hardy souls that went up to Montana and North Dakota in February, they saw it, but they froze too. Let's see, there was the 1971 cut across Florida, Georgia, hit Nova Scotia. If any of you are fans of Carly Simon, yeah. Remember the song? Mm-hmm. You're so vain. You took your Learjet and went to Nova Scotia. Yep. That was the eclipse that whoever the song was after, yeah. But before that, well, you look, the last time one touched Nebraska was in 1954. Started here right at sunrise, that's what that indicates, and of course zoomed off up to the northeast. There was one in 1834. Don't imagine there was too many people around here. A few of the Native Americans, maybe a few fur traders, whatever. So you can see, as a point, they're quite frequent, but to have one in any given spot is just pretty rare. Well, okay, solar eclipse is first time since 1979. Okay, let's look at in more detail the track is across the United States. There again, you saw some in the video. Here again, it comes in off the Pacific Ocean. Out here somewhere, the moon rises in eclipse and then starts the path. Hits the Oregon coast like 10:54, something like that. Pacific time. The path is moving, or the shadow is moving very fast. Anywhere from 14 to 1,800 miles per hour is how fast that path, because it only takes it then approximately 90 some minutes to go clear across the United States. Okay, what's shown here too is when it says magnitude, okay, you'll see a 90% eclipse, 95, 80, depending on if you're in the other parts. But we're in Nebraska, we're going to see it total. Well, all you got to do is drive down south from here. Okay, as I mentioned, the first time since 1954. Here are some more details of the maps for across Nebraska. Okay, it hits the state line out there between Wyoming and Nebraska in the Panhandle, 11:48 Mountain Daylight Time. Central Daylight, that'd be 12:48. 12 minutes plus 6, 18 minutes later, it leaves down by Fall City. The major towns you see, like Scottsbluff, Alliance, Nebraska, or North Platte, Broken Bow, Kearney, Grand Island's almost dead center. National Homestead Monuments, where Beatrice is almost dead center. Lincoln, yeah. If I was in Lincoln, I'd try to get a little further south to the center line. These numbers here are an indication of how long the totality duration will be. Hello? Okay. Thought it cut out there. As you can see right on the edge, yeah, you'll see seconds or minute. Obviously, you get to the center line. You got about 2.5 minutes, 2 minutes 31. You get down here to the other end of the state and you're up to 2:38, or 2 minutes 38, 2 minutes 39. So you weigh out how far you want to go and where you want to go to see totality. Okay, that's the whole state. Got a couple other closer ones. If you want to head out to central Nebraska, here's some of the towns that are in the path. These little towns of Tryon and Stapleton, they're planning up really big. They got all kinds of activities they're planning. Arnold, some things in Broken Bow. Ravenna, you see Ravenna, there's right on the center line. They got all kinds of activities they're planning for Ravenna. Next one. Here we are in the eastern part of Nebraska. Grand Island, Stir Museum. It hits Stir Museum almost dead center. Ravenna, Aurora, Geneva, Beatrice, and Auburn is going to be not too bad. You get pretty good. Fall City. There's a couple little towns down there, Pawnee City, Table Rock, if you're familiar with the southeast southeast Nebraska, are going to be good spots to watch this. Okay, next slide. Okay, here's a series of images. Okay, what's going to happen? Here's a series of images of the sun being progressively covered by the moon as totality approaches. These are taken through a telescope or a telephoto camera lens with proper filter in the front of the telescopes or the lenses. I wish we had a little darker room here. Can anybody see these? I mean, that's okay. Yeah, what happens? I'll have a little graphic here. The kids will love this. I have the moon will start taking a little notch out of the sun. Of course, these are all looking through filters. That's what we call first contact. When it first starts to touch the edge of the sun, and it progressively grows. About an hour and 20 minutes. You're getting down here, getting close. This is about how it will look here in Omaha. Maybe a little more taken out, but you'll never see the beauty of the total eclipse here in Omaha, or even here in Bellevue. Okay, hold that. I'll show you my demo. Kids, I can't hold this, so y'all have to yell. Here's my sun. Here's my moon. And here's what is going to happen. Everybody see? Of course, when the moon's out here, the sun is so brilliant, there's no way you can see that shadow. Of course, if it was 2 weeks later, you'd see it as a full moon. That's the side you would see, but you don't see it. It's just, you don't see anything until it starts to cross right there. First contact, when it hits the edge of the sun. And it'll gradually keep moving, keep moving. Hour and 20 minutes. Last little bit, we'll talk about that some more. And the sun disappears. Now, we live on a very unique planet, very unique time in the eons of history for this to happen. Yeah, to have the moon and to do the same size. And it really, sometimes it doesn't quite cover. You know, the moon runs in an orbit that is an ellipse, as all orbits are. Sometimes it's too far away to fully cover the sun. But we have, the uniqueness is The sun is 400 times larger than the moon, but it's also 400 times further away. So if those two physical facts make it possible for us to have total solar eclipses. I mean, we're the only planet in the solar system that can happen. All the other planets, the moons, or they're too far away from the sun, or they're too small to cover the entire sun. So that's why we have total solar eclipses. Okay, here's what a total solar eclipse looks to the unaided eye. Only when the moon is totally covering the sun is it safe to view without eclipse glasses. I'll be hammering on that in a few more slides. Here's what you'll see basically unaided eye, and when it goes total. It'll look like a black hole in the sky. Now, it won't get totally dark. Well, what happens, and here again, like I said, I've never seen it. All I've done, I've read, I've listened to other more or smarter people than me talk about it. But what happens is, in those last few seconds, as it's closing in to cover the whole sun, of course, the brilliance of what's left of the sun is still keeping your eyes, your pupils small, there's been daylight. And so when that moment happens, when it totally disappears, it's almost like, it plunges you into dark. Something like you're walking out of a bright room into the dark sky at night. It takes a while for your eyes to adjust. Maybe not quite as dramatic. And what we see here is what's called the corona, the atmosphere around the sun. And when the moon is fully covering the sun, that corona is going to be about like about the same brightness as a full moon. So it won't be totally dark, but you'll be able to see stars, the major planets, and everything stretched out on either side of the sun-moon combination. Okay, next. Okay, here's a view of the total eclipse through a telescope or long telephoto lens. I see I misspelled a word and my word checker didn't catch it. How about that? Here again, as long as the moon is totally covering the sun, you can gaze at it without the use of proper filters. More on that later. Okay, and when it gets total, like this, you can use your binoculars to look at and see a closer image like that. Only when it's totally covered. But you can take a standard pair of binoculars. Now, we'll talk about this in a second. I've already fitted these with filters, but for that 2 minutes, 30 seconds, I wouldn't push it on either side. Give yourself a few seconds before you put your unfiltered binoculars or telescope or whatever up there at it. But you can look at it like that and see. Now, I got another picture later on, because they say no individual photograph can begin to capture the full dynamics of the corona. Okay, next slide. Okay, the eclipse is bringing thousands of visitors to the state of Nebraska. I mean, numbers are wild. They're all over the place. The estimates are from 120 to 400,000 additional people showing up in this state to watch. I got anecdotal stories. I mean, probably too long to go into them, but I'm working with 40 Dutch astronomers that are coming in the 18th. They're going up to the sandhills. I've heard stories about Australians chartering in a 747 to fly into North Platte. I mean, there's some real crazies out there when it comes to this.
Hopefully we'll make some money.
Maybe. That's everybody's on the bandwagon to make some money out of this. The Beatrice. Well, yeah. The towns like Beatrice, they in the National Homestead Monument, they've been advertising for months on this. There are going to be a lot of people there. Okay. It has been a large undertaking to educate the general public on the safety issues of observing the eclipse. I've been doing a number of these. I know there's the staff at the University of Nebraska Omaha Physics Department. They've been in a number of talks. Lincoln's been having talks. We had, I don't know if anybody of you here caught it, but we had an international speaker in on June 27th, Dr. Kate Russo. She's one of these dyed-in-the-wool consummate eclipse chasers. She's also a doctor of psychology. She's written 2 books on the experience of watching the total solar eclipse. We had her in the UNO on the 27th, gave a great talk. So it's a major effort to try to get everybody up to speed on what's going to happen.
Is she from Belfast?
Belfast, yes.
Oh my God, that's
Yes,
not far from where I live.
She was born in Australia, originally from Australia. Moved to London, got her higher level degrees in London, met a fellow there. They've been living in Belfast. Her first eclipse was 1999, just off the coast of France, and it was such an effect on her that's, yep. Okay, next. Okay, so what do we got to do to be safe? Be prepared. Eye safety is paramount. You're going to see that over and over in the next few slides. Okay, viewing of all partial phases of the eclipse requires safety glasses or use of proper solar filters on any binoculars, telescopes, or cameras. Okay, time for a few more visuals. Okay, everybody's talking about solar glasses. Here's what we're talking about. They are totally opaque to any other light other than when you're looking at the sun. You've just heard them tell you how many they have here. As a fundraiser for the Omaha Astronomical Society, we do have, you know, somebody's desperate, we do have them. We're charging $1 a piece for them. So if you run short, I have some business cards. I can get a hold of you, or you can get a hold of me. Okay, that's the first line of defense. Here's another little clever device called an Eclipse card. Same thing. Maybe a lot of times it's either for young folks to use. You can just hold this up to your eyes. They're, again, totally opaque. Now, you've probably seen on the news all these stories about people trying to sell knockoffs and everything. When you look at these, they should have some kind of ISO, International Standards Organization number. You know, it says meets the requirements of ISO, yada, yada, yada. Or this is, there's an equivalent British Standards Institute. That's what these are certified for. So, yeah, I think most everyone you find is going, most every glasses you find is going to be safe, but just, you know, just to make sure. Now, when you get them, be very careful with them. You don't want to punch a hole in them. You don't want to scratch them, because if you do, then there's a potential that light beam getting through to your eyes. Okay, so that's the story on glasses. Here's an example of people using them. In fact, that's Dr. Kate right there. And you have to have them if you want to look directly at the sun. All partial phases. Okay, here's other options. Got to have filters. I brought a pair of my binoculars. They're fitted with commercially purchased, you know, certified solar filters, you know, screwed on the front so they won't fall off. With these, you can look at all the partial phases. Well, I can go out tomorrow and look at the sun too, yeah. And it's fun sometimes. You can see some neat sunspots even with like 7 or 10 power binoculars. But that's a safe way to look at a partial. Unless you really know what you're doing, I would suggest you buy already made ones. I have made some up myself with just buying this type of solar film and doing it, but this is the safest way. And you can get them like binoculars for your telephoto lenses, telescopes. Okay, next one. Yeah, there shows one fitted to a telescope, all set up with an equatorial mount. He's ready to take pictures of at least the partial phases. There again, I'm hitting, okay. Okay, now here we'll have to switch. This is a neat video. It's about 3 minutes long. And this gentleman there again, I know him as a personal friend. He's the CEO and president of what's called Explore Scientific Telescope Company.
So it's a beautiful sunny day, and we have you know, our refractor out, and I've got my Eclipse glasses on, and I've got my safe solar filter. Of course, the Eclipse is not here yet, but I wanted to take a few minutes just to show you some things about solar filter safety. The filters that we use is the Thousand Oaks material. It is rated to the highest ISO standards. And actually independently tested by us as well, so just to make sure that those standards are met. So if you're going to use a telescope to look at the partial phases, and let me underline partial phases to you, you use Eclipse glasses to observe the sun in partial phases when it's in total, if you're going to be on the path of totality, you can take the glasses off, and only during that time, which is going to be roughly 2 minutes this time on August 21st, only during that time can you directly look up at where the sun is, because it's completely blocked out. You'll see the corona, you'll see, you know, lots of really cool effects that they'll leave you speechless. But during all the partial phases, you have to have safe solar filtration. So how do you do it properly? Let me show you. First off, let's show you what you shouldn't do. What you shouldn't do is put on Eclipse glasses and look through the telescope that's unfiltered. And I'll show you exactly why here. We're going to point the telescope directly at the sun. And right now, we have sunlight coming right through the eyepiece. You know, I can turn that up a little bit. If you use solar glasses and look right at the filter material, you see it's already burning. It's burning a hole right through the solar filter material. That is how powerful a telescope is. So this is definitely something you don't want to do. You can now see that there is a hole through there, and that could be your eye. So this is what can happen if you think that you can use Eclipse glasses to look through unfiltered telescopes or binoculars. If you do that, the sun's energy is going to burn right through the filter and burn right into your eye. So if you're going to use a telescope or a pair of binoculars to watch the partial phases of a total eclipse, or just to observe the sun to look for sunspots or something like that, make sure that you are using an over-the-lens solar filter that has the proper ISO safety rating and all of that. And so what I'm going to do is I'm going to put this filter on. It's you can see how snugly it's fitting here. This is not about to come off, you know, if you have a loose fitting filter, use tape. Do anything that you can to make sure that the filter is not going to come off. And then the other thing is too is that finder scopes, optical finder scopes are like little telescopes, and they need to be filtered as well. In this case, I just have a red dot finder. There is no magnifying power to it, so I'm not going to use it to sight the sun in. The way I'm going to sight in the sun is literally as I'm going to look down at the shadow and align the scope up so I'm getting the smallest shadow possible of the telescope as it's hitting the ground. And now I can safely look at the sun in comfort and look at sunspots, and if we have partial phases going on in the eclipse, I'll see them all.
Okay, I felt that was worth including just to show you that, you know, I used to do little tricks like that with just holding a piece of card, you know, like a postcard or a piece of paper behind my eyepiece with it looking at the sun, and it'll instantly burn, start it on fire. So that's the risk. I mean, you got to make sure you know what you're doing if you're messing around with unfiltered telescopes. Okay, so where are we at here now? Okay, let's talk about ways that you can do this without needing glasses or without any fear of looking at the sun. I don't have a prop made up for this, but this is the old tried and true pinhole in the box. So that's a little fancier than the ones I've ever made, but it's basically taking a cardboard box, cut a hole out one side here, paste or tape a piece of aluminum foil over it, and punch a little tiny hole. You go down the other end, tape or glue a white sheet of paper, and then you just kind of, with your back to it, you line up until you see a little small image. Now, small is the word here. It's usually the image as it develops the crescent. It is pretty tiny, but you can definitely see it go through as the moon takes more and more bites out of the sun until total. You know, if you're in the path of totality, of course, it's going to disappear once it's total. Okay, let's see. Do I have any more? Okay, one more, and then I'll show you some of my hand props. Here's another one. I actually made one of these. You got to know a little more about what you're doing here, but this is called the solar funnel projection system. And what you do is you can get one of these funnels, you know, at any auto parts store. They're the ones I use to fill transmissions where you got to have the long neck on it. You find you some back projection screen, or just some, you know, maybe even an old shower curtain that's, you know, opaque. Get you some couple hose clamps. and figure out the dimensions and stretch that. And of course, find an old eyepiece. That's what we use to look at stuff when we're at night. My own personal experience, make sure the eyepiece you put in here is an all metal eyepiece. I grabbed one out of my junk box and, this is just a little cheap old eyepiece. Okay, so I put it in there, put the hose clamp, put it on I had just a little 80 millimeter refractor I put it on. And I was trying to line it up, and all of a sudden the image started getting all wiggly. And, this started looking really weird. I thought, what the? And then I looked down there and I could smell plastic melting. The housing of that eyepiece was plastic, and it did a number on it. So you got to make sure you got a metal one if you're going to try something like this. Okay, a couple of other neat ideas. How many know what these are? The good old macaroni and spaghetti colander. I've been on the lookout for a few months and I found this one. Everybody see what the pattern is on the bottom of this one? It's a star. So I thought, oh cool, I got to have this. Well, there's all stars in it. I don't know if I can show here, but let's try. I don't have a bright, but you can. Yeah, you'll see it diffuses the light. Now, the tremendous light of the sun and all the partial phases, those in the back, you can come up later. What you end up seeing is literally tens, if not hundreds, of little tiny crescents when you use this and all the partial phases. And there's another one, just a couple ideas. Where I'm going to be going, I'm going to have little demos like this to entertain people, because like I said, you got an hour and 20 minutes. Got an hour and 20 minutes before the from when first contact fully covered, so you got to have something to do to kind of entertain yourself. So that's an idea.
What are you going to see?
I'm not telling. I'm not telling.
Not going to be educated.
I'll put it this way. I'm going to be in Pawnee County if the weather looks good and everything's fine. So that narrows it down to at least something.
Oh, that's fun.
Down there where it's about 2 minutes and 38 seconds. Okay, using the back, well here, I'll use the bigger one. Little round compact mirror. We'll project a round circle of the sun, and when it's going partial, it'll project the crescent. Now, the bigger the mirror, the further away you have to get to reflect it. So you want to be standing somewhere where you can catch the sun and then reflect it onto the side, the shadow side of a building or a piece of cardboard, white, cardboard or something set up, and you can project the image, onto that. I was playing with this the other day, and I had to be about 60, 70 feet away from the shady side of my house for it to be kind of a nice clear image. But of course the image is pretty big. I mean, I'm holding it here, but the people up, you could walk up and you could see probably a 12-inch disc of the sun. Went something a little smaller here. I just picked up these. This idea I'm going to glue these to a sheet, maybe 6 or 8 of them to a sheet, maybe in some kind of pattern, and have that set up so that you can reflect onto a white sheet and you'll have all kinds of little tiny crescents showing up. So there's a couple other ideas to use that you don't have to worry about making sure your glasses won't hurt anything. So just some ideas to throw out to you to enjoy the eclipse. Okay, what do we got next here? Safety concerns. Okay, other ideas. Okay, staying hydrated. This is August. Now granted, we had 2 or 3 days of pretty decent cool weather here, but what is it, what is it going to be on the 21st? No weatherman's willing to predict yet. So you have to stay hydrated, make sure you have water, sunscreen, especially those you have a fair complexion, you better have some sunscreen on, you better have hats on if you're out in it so you can protect. I mean, you'll be out there if we're going to stay the whole thing. Because most people, once totality is over, or the maximum coverage, everybody kind of loses interest and wanders off. But I'll have telescopes set up for the entire 3 hours. Because it's fun to watch it move back out too. Hopefully you'll be aware area where you can have some shade to cool down. Maybe one of these little pop-ups like the tailgaters use and everything, so that during the partial phases you can cool down. This could be really important. Restrooms. Plan ahead. If you end up in an area where there's hundreds, if not thousands of people, you know, better make sure they got enough porta potties up there. And not that I want to be, but maybe you better take a little extra of that just in case, because everybody takes a run on the restrooms and boom, it's all gone. But just some ideas to think about if you're headed out somewhere where where you're going to be in totality. A few other things. If you are, we've heard different traffic projections. I don't know. My own feeling, I'm telling people when they ask me personally, well, where should I go? Well, if you're near Omaha and you really don't want to try to fight the crowds out down at Beatrice or out at Grand Island, head south on 75 or on Highway 50. You know, 75 is, you know, a little bit better highway than Highway 50, but you get down. If you're going to Highway 50, you got to get to at least Syracuse, maybe Tecumseh, to, you know, maybe then pull off a side road and you can see it there. As I said, I'm going to be around the Pawnee City, that area. Go down 75, you go down to like around Fall City, you have to go a little further south. I'm just saying that traffic-wise, Interstate 80, that Monday morning could be crazier than the worst traffic to Cornhusker football games you've ever experienced. Yeah. Plan ahead. Hey, well, and I don't know. You know, like I said, I've made arrangements. I'm going to be down there Saturday, so I don't have to worry. But other than if it's cloudy, comes cloudy, and I'm going to be stuck there. But plan ahead and think about, you know, if you really seriously want to get in the path, you know, plan a little logistics out. So let's see. I think we're getting close to the end here. Okay, back again. When totality arrives, and only then can you observe the eclipse without eye protection. No single photograph of a total solar eclipse can come close to conveying what the human eye can see during totality. This next image is a composite of several images taken together and then combined to show you the extent of the solar corona. Now, there again, it's probably not dark enough in here to really see all these little wisps that stream out from the edge. Now, sometimes you see these little pink projections. These are the solar flares that are coming off the edge of the sun. It all depends on how active the sun is. Right now, the sun has been very quiet is the term. There's been very few sunspots. Of course, the sun rotates in what, about 25, 26 days. So these are like storms or sunspots, magnetic storms that are on the edge at that point. You know, sometimes they're in the middle. You see them, if you're looking through a filtered telescope, you see these little black dots and everything. So I don't know. All I know is we'll see corona to some extent. Okay, what else? The splendor of totality. You cannot completely prepare yourself for the sight of a total solar eclipse. I've been told. And when totality arrives, you will experience primal emotions, wonderment at the unspeakable beauty of the corona and the display of colors and lights as you've never seen before. You may involuntarily scream, gasp, perhaps even cry at the astounding vision. The splendor of totality. The final short video is an attempt to depict the sights, the feeling, and the emotions of being in the shadow.
Whoa! Whoa! Wow! Oh man! Fantastic! Woo!
I think I had a few websites here. We can leave that up for a little bit in case anybody wants to jot them down. The top one, whoop, back up just a second here, yeah. The top one is the website for our Omaha Astronomical Society, which if you get that one written down, I think all these others are probably listed on one of our pages or tabs there. Great American Eclipse, got a lot of good information. I think this, okay, this one's got, well, it's too long, but I think it's, we have it there. It shows you some details. There's an interactive map out there where you can click on, and with the Google Map things, you can zoom in, click on a spot, and it'll give you the exact times for when that first contact, the exact times when full totality starts, exactly how long it lasts, when it ends. So things like that. And if those of you picked up that checklist, you notice there's, like it says C2, C2, or C1, C2, C3. C3 is probably the most important to be aware of because that's when totality ends, and you want to make sure that you're not looking through, or, well, C4 is when it finally, the partial phase. Okay, I see, they have an extra one. Okay, they got C3 for center, which, okay, yeah, C4, okay. Okay, anything else? Okay, well, we can leave that there for a little bit because the last slide just said questions. So.